students. So this is our lecture number 2. And in this lecture, we will proceed further from our previous lesson, which we already covered up. The previous lesson finished at uniform velocity concept, and we have done one numerical based on that as well. Now, question arises that basically, what if the velocity is not constant or speed is not constant? As I told you previously, I can interchangeably use speed and velocity. Let's suppose this is your car. At this point, let's suppose the car has a velocity of 4 meter per second, right? The car has a velocity of 4 meter per second. And let me just bring up once again, right? Let's suppose at this point, the car velocity is 4 meter per second. And once suddenly something happened and it has to be increased, and while it reaches A, the velocity increased by 8 meter per second. Then at this point, the velocity increased to further 12 meter per second. In that case, now you can't just take the average velocity, or you can say it's a uniform velocity, because it's not a uniform velocity, right? So in that case, now you got different velocity. You can say that velocity, or anything which you have seen first, is considered to be initial velocity, and the velocity which it ends up, or you actually just finishing watching things, is your final velocity. So a new quantity just arises here, and you call that quantity as acceleration. Remember that acceleration is a vector quantity, which means it has a direction. So what exactly is acceleration then? Acceleration is the rate of change of velocity, not speed, because it's a vector quantity. So basically, what does it mean is acceleration is equal to change in speed, or change in definitely velocity, divided by time. Whenever you use a word rate, it means divided by time, right? So basically, it can be like this. Now, let's suppose this is a car. It has an initial velocity u, and after time t, the speed changes to v. So initial velocity is u, final velocity is v. So how do you actually explain that? How will you find out the change in velocity? So change in velocity is equal to final velocity minus initial velocity, right? In that case, the final velocity is v and initial velocity is u. So what is acceleration in form of symbols? It will be v minus u divided by t. T will be time. So this is the formula for final minus the initial velocity. And what will be the unit for that? Numerator, the unit is meter per second, the SI unit, and denominator is seconds. So basically, the unit of acceleration is meters per second square, right? This is the unit of acceleration. Now, there are 2-3 things which are very, very important in this case. The question arises, I said change in velocity upon time. What if a car is chasing someone and it has to increase the speed? It means that it has some initial velocity v and it has to increase. It means the final velocity v is more than u. In that case, your acceleration value will be a positive value, which means that speed or velocity is increasing, right? But it can be other way around as well. If a car is moving, suddenly a child or a boy or anyone comes in front. So driver has to stop the car, puts the brake on it. So what will happen? In that case, V will be less than U, right? In that case, your acceleration will be negative. Remember that as far as positive acceleration is concerned, it is named as acceleration. But when the acceleration is negative, which means that velocity is reducing, it is named as deceleration. Or there is another name for that, retardation. Right? Now let's see an example for that. Let's suppose a car has moving with the velocity of 50 meters per second, right? After time t is equal to 10 seconds, the speed increased to 100 meters per second. Now, question is, what will be the acceleration produced? So it will be very simple. 100 minus 50 divided by 10, which is 50 divided by 10, which is equal to 5 meters per second. It means that in each, you can say second, if the time is 10 seconds altogether, the speed acceleration will be 5 meters per second. Right? So within 10 meter per second, I mean, within time t is equal to 10, the acceleration is 10. 50 divided by 10, which is 5 meters per second. Very simple case. It simple means that in each second, the speed is increased by 5. The first second, the speed increased from 50 to 55, then 55 to 60, and so on. In 10 seconds, the speed increased to 100 meters per second. So this is what the acceleration is all about. Now, we will start the topic. I will explain a bit of it, and then later will be in the next lecture. To further explain and definitely go for the calculation one, there are graphs which are explaining all these things. We call them kinematics graphs. First type of graph is called as a distance time graph. And second type of graph is called as speed time graph. Now, as I told you previously, we can use interchangeably distance instead of displacement and speed instead of velocity until particularly the direction is being mentioned. Now let's talk about distance time graph, some standard distance time graph. In distance time graph, remember that distance will be taken on y-axis and time will be taken on x-axis. So it's like this, right? If this is the case, right? If the graph shows like that, what does it mean? Straight line parallel to the x-axis, it shows that distance is not changing. Distance is constant at any point, which means body is at stationary. Because distance is not changing at any point, at any time, and this means that body is at stationary. Second type of graph is this graph. A straight line passing through the center. Now, what does it mean? It tells you that body covers equal distance in equal intervals of time. Like if I draw a line like that, the body covers equal distance in equal intervals of time, which means speed is uniform, which means constant velocity. Now, how to find out that constant velocity? Because the line is straight, right? You can find out the gradient of a graph. gradient of the distance time graph, to find out the constant speed or constant velocity. And what is gradient in mathematics? You can take any 2 points on these lines and then you will apply a formula which says y2 minus y1 divided by x2 minus x1. That is a gradient. Actually, this will give you the value of velocity, or you can say speed, constant speed. All right. Then you have another kind of graph which is called speed time graph. Now, what is the speed time graph? If a graph is a straight line and on a y-axis you have speed, it means, because it's a straight line parallel, it means speed is not changing. So it's a constant speed graph because the speed is not changing. What about that? What does it mean then if the line is passing through the origin and going straight down? It means that body covers equal, body has an equal speed in equal interval of time. There is a change in speed or change in velocity at the equal interval of time, which means body is covering a constant acceleration or uniform acceleration. Remember that we have constant accelerations in our course only. So it means that body will have an equal change in distance per unit time. So it's called a constant acceleration graph, right? How to find out that value? Again, you can find the gradient of a graph to find out the acceleration. So acceleration will be equal to, again, you can take 2 points on the graph and it will be y2 minus y1 divided by x2 minus x1, right? This will give you the acceleration, constant acceleration. That graph can be like that. What does it mean if it comes from some highest point on the y-axis and reaches to the x-axis? Same. Now, what does it tell you? It tells you that body is a decelerating constant. You can find the deceleration by doing the same thing, gradient of the graph. Okay. So now there can be another kind of graph as well, which is a non-linear acceleration. In that case, if you will have a velocity graph like that, now this is called non-linear graph. In non-linear graph, if the graph is like that, it means gradient is increasing, which means acceleration increasing. And if the graph is like this, one graph is this and one graph is that, which means gradient reduces, which means is technically acceleration reduces. So these are the type of graphs we have it, okay? One thing is very important. The gradient of distance time graph is a speed or velocity, or gradient of velocity time graph is an acceleration. So students, in this lesson number 2 or lecture number 2, we have covered what is acceleration, and we have seen some kinematic graphs, which is distance time graph and speed time graph, and we've seen some very basic types of them. In the next lectures, in the next lessons, we will do some calculation and we will see that what are the things we can easily find out from these graphs. Like I already told you, the gradient, if you find out for speed time graph, you will find out acceleration, and from distance time graph, if you find out the gradient, you can easily find out the speed. But even if you find the area under the curve for the speed time graph, you can find out the distance covered as well. And these are the calculations which we will do in the next class. So keep watching my videos and hope to see you in the next video. So for this point of time, it's bye from my side. See you in the next lesson. Bye.